The graph shows the heights of 28 children in Alfie's class to the nearest centimetre. Alfie is 153 centimetres tall. He says only one person in my class is taller than I am. Emma says you can't tell this from the graph. Explain why Emma is correct. So if we look at our bar graph, we can see that we have the number of children and their height in centimetres. Alfie is 153 centimetres tall, so he's one of the children in this bar here. We can see that two children, because if we read across we get to two children are between 150 and 159 centimetres. One of these children is Alfie, because he's 153, but the other child could be 154 to 159, so could be taller than Alfie, but still part of this bar. So as well as the one child in this bar who might be taller, we have another child here. There is also another child who is at least 160 centimetres tall. So there's one child that we know is taller than Alfie, and then there's another child that might be taller than Alfie if they're 154 to 159 centimetres. Match each shape on the left to one with equal area on the right. So we need to remember that the area of a shape is how much space it takes up. So this shape here has an area that's the same as 4 squares, because we have 2 halves here which can make one whole, we have 2 halves here which can make another whole, and we also have 2 full squares in the middle, so that's 4 squares altogether. Now for this shape, on the left we have 2 half squares, so that's 1 square altogether, and on the right we have 2 half squares, so again that's another one altogether, so we have 2 full squares altogether, because if we have 4 half squares, that's the same as having 2 whole squares. Now for this shape here, we can see that these 2 half squares make one, these 2 make another one, and these 2 make another one, so that's 1, 2, 3, then we can count 4, 5, 6, 7, so we need to match this to the area that has 7 squares. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 half squares altogether, and half of 10 is 5, so the area is the same as 5 whole squares. Work out the missing numbers below. The first one is done for you. So we're told the first 5 multiples of 4 add to 60, because 4 plus 8 plus 12 plus 16 plus 20 is 60. So remember, a multiple of a number is in that number's times table. So the first multiple of 4 is 4, then the second multiple of 4 is 8, because that's the second number in the 4 times table, and so on. So now, the first 3 multiples of which number add to 60? Well, the first 3 multiples of 10 add to 60, because 10 plus 20 plus 30 is 60. So those are the first 3 multiples of 10, and adding them together gives a total of 60. Now use different numbers to complete the sentence below. The first, how many multiples of which number add to 60? Well, we could have the first 2 multiples of 20, because 20 plus 40 is 60, so multiples of 20, numbers in the 20 times table, and when we add the first 2 of those, we get 60. There is another possible answer. We could have the first 4 multiples of 6, because the first 4 multiples of 6 are 6, 12, 18, 24, and those numbers total 60 as well. So how could we solve this question without just trying lots of different things out and seeing what works? Well, one shortcut is to spot that the numbers in these boxes here have to be factors of 60. So 10 is a factor of 60 because 60 is in the 10 times table. 20 and 6 are factors of 60 as well because 60 is in both of those times tables as well. We could also, for this first one, use bar models, so that we know that we need to find the first 3 multiples of a number. So for the first multiple, we can draw 1 bar. Then we can draw 2 bars for our second multiple, because that shows 2 times the number. And then we can draw 3 bars for our third multiple, because that shows 3 times the number. And we need to add up to 60, so we know that all of these bars together will total 60. We have 6 bars and they need to total 60, so each bar is 10. So we have 10, then 20 because that's 2 bars, then 30 because that's 3 bars. Debbie has a pack of cards numbered from 1 to 20. She picks 4 different number cards. Exactly 3 of the 4 numbers are multiples of 5. So remember, multiples of 5 are numbers in the 5 times table. So we could have 5, 10, 15 or 20, and she has 3 of those numbers there. Exactly 3 of the 4 numbers are even numbers. So even numbers are multiples of 2. So numbers like 2, 4, 6, 8 and so on. All 4 of the numbers add up to less than 40. Write what the numbers could be. Well, we know one of the multiples of 5 that isn't one of the cards has to be 5 or 15 because we need 3 even numbers. So we know that 10 and 20 must have been 2 of the cards because we know that 3 of them were multiples of 5 and 3 of the 4 numbers are even numbers. So one of the multiples of 5 is one of our odd numbers, or our only odd number. The multiple of 5 that is one of the cards has to be 5, because the numbers have to add up to less than 40. And if we have 10, 15 and 20, that's 45, so more than 40. So the other multiple of 5 must be 5. So 3 of the 4 numbers are multiples of 5, so that must mean 5, 10 and 20, because they need to add up to less than 40. So now 20 plus 10 plus 5, so the numbers that we know that she must have chosen add to 35. So the other number has to be 2 or 4, because it has to be even, so a number in that's a multiple of 2, and the total has to be under 40. So she might have chosen 2 as her even number card, or 4. So the numbers could be 4, 5, 10 and 20, or 2, 5, 10 and 20. Write what the 3 missing digits could be. So we have a 2-digit number times 3 equals a number with 8 tens, and we don't know how many ones. Now when we have a missing number multiplication, we can divide to find our missing number. We don't know what our answer is, but let's try 81 to see if this digit here could be a 1. So remember, if we don't get a remainder, then our answer will be the answer here, so the missing numbers here. 81 divided by 3 is 27, so that means that 27 times 3 is 81. So we can have 2, 7 and 1 as our missing digits. We could also have 28 times 3 is 84, or 29 times 3 is 87. Circle the number that is equal to 99 thousandths. So here we have decimals, and we need to remember that the first digit after the decimal point tells us how many tenths we have, then the second digit tells us how many hundredths, and it's the third digit that shows how many thousandths we have. So we have 99 thousandths, and the denominator of 1,000 tells us that we need 3 digits after the decimal point, because our third digit after the decimal point is our thousandths digit. So we write 99 thousandths as 0.099. So we can only have one digit in each place value, which means the first 9 in 99 gets pushed to the left, so pushed over into our hundredths column. Then we need to remember to write a 0 in our tenths column to make it clear that what comes next is our hundredths and our thousandths, and a 0 before the decimal point, because we don't have a mixed number, we just have a fraction. So we need to circle 0.099. In this diagram, the number in each box is the sum of the two numbers below it. Write the missing numbers. So we know that the number in this box will be the sum of these numbers here, these numbers below it. So we need to work out 2 3/4 plus 3 1/2. We can add mixed numbers by first changing them to improper fractions. 2 times 4 is 8, plus 3 is 11, and the denominator stays the same. 3 times 2 is 6, plus 1 is 7, and the denominator stays the same. But to add fractions, we need a common denominator. So rather than 11/4 plus 7/2, we can work out 11/4 plus 14/4, because that's equivalent to 7/2. 2 times 2 is 4, 7 times 2 is 14. So that gives us 25/4, and turning that back into a mixed number, we have 6 1/4, because 25 divided by 4 is 6 remainder 1, and the denominator stays the same. Or because 6 times 4 is 24, plus 1 is 25, and that's the numerator of our improper fraction. But now let's find this box here. We have something plus 1 1/4 equals 2 3/4, because remember, the number is always the sum of the numbers below. So if we have a missing number addition, we need to subtract to find our missing number. So we can work out 2 3/4 minus 1 1/4. 2 3/4 is 11/4, and 1 1/4 is 5/4, because 1 times 4 is 4 plus 1 is 5, and the denominator stays the same. So we get 6/4, which as a mixed number, we can write as 1 2/4, because 6 divided by 4 is 1 remainder 2. So then we could check 1 2/4 plus 1 1/4 is 2 3/4. We could also write 1 1/2, because that's the same as 1 2/4. 1/2 is 2/4 simplified. Tickets for a school play cost £2.75 each. Dev sold 23 tickets. How much ticket money did Dev collect? So he sold 23 tickets and got £2.75 for each of them. So we need to multiply £2.75 by 23. Remember, with column multiplication, we write the number with the most digits on top. Then we need to remember to copy down our decimal point, and now we can just multiply in the same way as if we had 275 times 23. So when we use column multiplication, we get £63.25. So that's how much money Dev collected. Now, Holly collected £77 altogether from selling tickets. How many tickets did she sell? So really, we need to divide £77 by £2.75. But the quickest way to do that is to count up from £2.75 until we get to £77. So one ticket costs £2.75. And that means 2 tickets must cost £5.50, because £2.75 times 2, or £2.75 plus £2.75 is £5.50. 4 tickets will cost £11, because 2 times 2 is 4, and £5.50 times 2 is exactly £11. So that means 28 tickets cost £77. 4 times 7 is 28. 11 times 7 is 77. So that means she sold 28 tickets. Complete this 2-digit number so that it is a multiple of 6. Now we need to remember that a multiple of 6 is just a number that's in the 6 times table, and 72 is in the 6 times table, so is a multiple of 6, because 12 times 6 is 72. We could also have 78, because 13 times 6 is 78, and if it's in the 6 times table, it's a multiple of 6. But remember, the 6 times table doesn't stop at 12 times 6. We can have the answer to 13 times 6 as our answer as well. The perimeter of a rectangle is 1 metre. Each longer side is 36 centimetres. What is the length of each shorter side? So we have a rectangle, and we know that both longer sides are 36 centimetres, but we need to know the length of the shorter sides. To do that, we need to remember that the perimeter is the distance around the outside of the shape, and we know that 1 metre is the same as 100 centimetres. So 36 plus one shorter side plus 36 plus another shorter side will be 100. Now 36 plus 36 is 72. So these longer sides together are 72 centimetres. If we subtract that from 100, we know that the 2 shorter sides together will be 28 centimetres. But we need to know the length of each shorter side, so the length of one shorter side. Because we know that 2 shorter sides total 28, if we divide 28 by 2, that gives us 14, so we know that the shorter sides must be 14 centimetres. And then we can check that 36 plus 14 plus 36 plus 14 is 100, because we know that the perimeter is 1 metre, and 1 metre is 100 centimetres.